Hey guys, and welcome back to our next set of notes. Today is going to be talking all about chemical reactions, the process by which we take one set of chemicals and turn them into something completely different. Kind of like how we talked about the chemical changes before. You start with one set of substances and you end up with something new and different. The same idea explains chemical reactions. And so today we're going to talk mainly about how we can observe if a chemical reaction is happening. What are some of the main principles of chemical reactions? And what are some of the different types of reactions that we might observe? So with that, let's get into the notes. All right, here we go. So chemical reactions are the ways that chemicals interact with each other in the natural environment. So chemical reactions are all about a change happening, changing one substance into something new. So at the end of a chemical reaction, we should have a new, different substance than what we had at the beginning. There should have been some sort of change happening to give us a new set of matter, some new combinations of molecules or elements. So some reactions that are going on every day in the world around us include growing. So not only does your body do a series of chemical reactions in order to give you energy, in order to walk, talk, eat, and breathe, but also when you go from a little baby into a full-size adult, there's a lot of growing and changing that's happening inside of your body. And that is all due to chemical reactions. Same thing with our friend, the caterpillar right here. He's little right now, but as he's eating, his body is digesting the leaves and turning them into energy. And then eventually, he's going to spin his cocoon and go through a really intense chemical reaction that will change all of his body parts around into the butterfly that he'll eventually become. There's ripening. So this is when you start off with a fruit like this mango or like banana, and it starts off as its unripe color. So in this case, we have like this greenish color down here is unripe, or not banana when it's that really bright green. And then over time, they change and they become ripe. On this mango, or maybe it's a tomato, you get this orangey reddish color coming in. And on a banana, it turns yellow at first when it's perfectly ripe, and then brown and dark when it's overripe. That's due to chemical reactions happening inside of the tomato or mango or banana or whatever you have. That's changing the initial set of molecules that's making that banana green into a new set of molecules that is making it yellow or even then brown. Decomposing is another major set of chemical reactions. There we go. So you leave out a bread or some bagels or a fruit for way too long, and eventually it'll start breaking down. What's happening is that things like bacteria and fungi are moving onto your bread or your banana and chemically breaking down, chemically changing the substances that are there into food that they can use for themselves. So this is why bread will grow this mold on it. Bananas will start becoming really stinky and smushy. And that's because of decomposing that's going on as the banana interacts with the bacteria and the mold that is in the air. And then finally, like we talked about with our chemical reactions and chemical changes, burning or combustion is another major chemical change. So we're taking this wood that's made up of a lot of carbon inside of these logs and changing that into heat and light, carbon dioxide gas, and the ash that's left afterwards. So all of these are different kind of common everyday chemical reactions where one substance is changing into something new, a new set of substances. So there are 6 kind of major signs that a chemical reaction could be going on. Bubbles might appear, like in this beaker over here, we've got a whole lot of these little bubbles, or like when you drop in an Alka-Seltzer tablet into a thing of water and all of a sudden it starts fizzing and going off. those are signs that a chemical reaction is occurring. You could have a new solid that forms. So like if you take one set of liquids and another set of liquids, mix them together, and then all of a sudden some solid kind of powdery stuff starts bubbling up in your mixture, that's a sign that a chemical reaction is going on, creating that solid where there didn't used to be one previously. A color change happening. So this is another common chemical reaction sign. Just like with the bananas we were talking about earlier, as they go from unripe to overripe, they start as green and then change to yellow and then change to brown. That color change is due to chemical reactions happening inside the skin of the banana. Now, this does not mean that when you take your purple Kool-Aid mix and you pour it into the water and stir it around, it becomes purple. That's not the kind of color change we're talking about here. We're talking about more like if you take two clear liquids and mix them together and all of a sudden they turn blue. So an unexpected color change or a color change happening over a long period of time is a good sign that a chemical reaction is happening. If you get a sudden temperature change, so things get really hot or really cold all of a sudden, that's another good sign of a chemical reaction. So like with the combustion and the burning we were talking about earlier, the fire in the wood obviously is going to be really hot. Same thing with these little packets that we don't really have here in Texas because it doesn't get that cold. But in other places like Ohio and Minnesota where it does get cold, they have the little hand warmer packets that are room temperature to start with, but if you squish them and kind of shake them up and put them inside your glove, they heat up and provide your hand and fingers with some extra warmth. So that's because a chemical change is happening inside of that little packet. A chemical reaction is going on when you squish it up and allow the chemicals to mix together. Light is another good sign that you have some sort of chemical reaction happening. So a lot of times we think of this with combustion. So stuff like fire produces a lot of light. That's due to the chemical reaction giving off energy from the reaction in the form of light. And then finally, if a sudden change in smell or taste occurs, that's a good sign that a chemical reaction is happening. So all of a sudden, this new odor is being released that definitely wasn't there before, or baking is a sign, is an example of chemical reactions that can happen every day inside your house. Right? You take all this liquidy, mushy ingredients, mix them all together, stick them in a hot oven, and all of a sudden they come out as something delicious and tasty. That's due to chemical reactions happening inside of that dough, inside of that cake mix or whatever it is that's leading the tastes to change and become more delicious. So like I said, we got bubbles going on in this little container over here. Another example of light besides just fire is what's called bioluminescence. So this is what happens in some jellyfish and some algae, and also fireflies do this too, where they give off light inside of their cells due to their cells causing a chemical reaction to happen, usually using some sort of enzyme that releases light as part of the reaction. So all 6 of these are signs that a chemical reaction is occurring in your matter, in your substance. So, like I've been saying, a chemical reaction is all about a change where you have one or more set of substances that's converted into new substances. And that's really the big thing about chemical changes and chemical reactions, is that we end up with totally new substances, totally new compounds and elements that we didn't have present that they were before. So we can show a chemical change happening on paper using something that sort of looks like a math formula, but is a little bit different. We have what's called the reactants on one side. So these are the substances that react together. Makes sense. Reactants react. So these are our starting substances. So they are what we use to start the chemical reaction. After they go through the reaction, we end up with the products. So the products, like you might imagine, are the substances that are produced as a result of our chemical reaction. So they are our kind of final products, our final answers. So we start with our reactants. They do some sort of chemical reaction, and they turn into our products. So this little arrow guy down here, this is sort of like the equal sign in a math equation. Only in this case, instead of just being equals, it stands more for like yields or produces or creates the products. So the reactants turn into the products due to this chemical reaction happening. But those are the two major kind of takeaways from this slide. Reactants are our starting material that react together. Products are our final set of chemicals that we end up with. So they are produced at the end of our reaction. So chemical reactions aren't gonna add or take away any completely new or different atoms. All they do is rearrange the atoms that we have into different sets of compounds and elements, into different arrangements than what was there before. So let's take photosynthesis, for example. Photosynthesis is the process by which plants absorb light and turn it into energy. So photosynthesis gives us plant energy. So in photosynthesis, it looks like a big, long, complicated reaction. You don't have to memorize it, but pay attention to our starting and our ending atoms. So we start off with carbon dioxide. We have a C and an O. And we also need some water, which is H2O. So we have some H's and we have some O's. So on our reactants side of our equation, we have C's, we have O's, and we have H's. We get some energy from the sun in the form of sunlight, and we turn it into glucose, which is a sugar molecule that the plant is going to use for energy, and oxygen. So plants give off oxygen, and that's what allows us to breathe. But notice, glucose is made up of C's, H's, and O's all together. So this is something new that we didn't have before. Before, our C's, H's, and O's were kind of spread out. Now we have one molecule that has them all together. And we have some oxygen, which is just the O's by themselves. So if we look at the atoms that we have on our product side, so these are our products, remember, our final things that we produce are glucose and oxygen. We have C's in the glucose. We have H's in the glucose, and we have oxygen not just in the glucose but also on its own as its own molecule. So our starting atoms and our product atoms are the same types of atoms are present. We didn't add or take away any new or different atoms. We just rearranged the atoms that were already here. So we rearranged this C, this O, and this H from CO2 and H2O into glucose, C6H12O6, and oxygen, O2. So the atoms just got rearranged. We didn't add or take away any atoms. And that's an important part of chemical reactions, is that we can't just create new atoms out of nowhere. We have to work with the atoms that we already have and use some sort of energy or something in order to create different sets of the same atoms. Oh, look at that, it's already on the slide. So the reactants on our left-hand side are starting stuff, and the products on our right-hand side, our final products of the reaction. The other important thing to know is that not just atoms are conserved in chemical reactions, but also energy is conserved as well. So any energy that goes into a reaction has to get stored or released as the products of the reaction. So we cannot create or destroy energy. The energy going in has to equal the energy coming out. We can change that energy from one form to another. So overall, the total amount of energy is going to be the same at the beginning and end of the reaction, but the types of energy, the forms of energy might be different. Like say, for example, we want to turn on a light bulb. Seems pretty simple. You send in electricity and you give off some light. Well, the energy going into that light bulb in the form of electricity, let's make it nice and easy for us. Let's say that there's 100 units of electrical energy that's going in. And so the way that a light bulb works is there's a little filament that's on the inside, the little wire part, that gets heated up. And as that gets heated up, it gives off some of its energy in the form of light, which is what we use for the light bulb. So we need energy to heat the light bulb, and we need energy to come off as light from the light bulb. So in this case, we're going to use 95 of that original energy in order to heat up the filament on the inside of the light bulb, and 5 of that original energy will come out of the light bulb as light. And so when you turn on a light bulb in your house, most of the energy for that light bulb is just going into heat. Heat that's going into the filament of the light bulb. That's why if the light's ever been on for a while and you go to touch it, it gets really hot and it can burn your hands. That's because the filament is heating up and giving off a little bit of that energy as light. So energy is conserved. Same amount of energy at the beginning. We have our 100 units down here. And at the end, only this time it's in the form of 5 units of light and 95 units as heat. When we do photosynthesis, like we were looking at earlier, that's also an example of transforming energy. So we have light energy that comes in from the sun. Whoop, too far. So here we have light energy that comes in from the sun. That goes into the plant and is stored as chemical energy in the form of sugar, like in fruits, like these grapes. And then when we eat the grapes, we turn the plant chemical energy into human chemical energy. So we eat those grapes, we get that sugar and chemically change it into energy molecules that our cells can use to power our body. So we transform energy from one form into the other. We have the same amount of energy overall, but the light energy from the sun gets transformed into the plant sugar chemical energy in fruit and parts of the plant, and then that's transformed into human chemical form of energy in the form of a little molecule called ATP. We don't have to worry about him right now. If you ever take biology, you'll learn a whole lot more about ATP. But again, we're not getting rid of or creating new energy, we're just changing it from one form to another. So there are 2 major types of reactions that happen with these different types of chemical reactions. We can have reactions that release energy and reactions that absorbed energy. So first up, we have exothermic reactions. So exo in science means like out, like leaving. So exothermic reactions are ones that release energy into the environment. So part of the chemical reaction involves giving energy off into the environment. A lot of times, this energy will be in the form of heat energy. So because of the energy given off from the reaction, the surrounding area will get heated up because that energy will increase the heat of the atmosphere around it. So like the fire that we were talking about, like on this little matchstick guy right here, or the little hand warmers that you squish up, those are very exothermic reactions. They give off a lot of heat. Digesting food is also an exothermic reaction. So the internal temperature of your body should be pretty close to 98.6 degrees Fahrenheit, which is obviously, for the most part, except for August in Texas, but otherwise, for the most part, that's a lot hotter inside your body than the air around us. Like in my house right now, I think it's about 76 degrees. So your body constantly needs to be generating heat in order to keep your body temperature at that optimal 98.6. One of the ways your body creates a lot of heat is through digesting food. So breaking down food into big chunks through smaller and smaller and smaller pieces. While that's going on, a lot of energy and a lot of heat energy is being released. Decomposition also produces energy. So if anybody knows, like people who have compost piles, who throw all their like food waste and stuff into a big pile, the interior of those a lot of times will get pretty hot because as the bacteria break down the food and the soil that you put in there, they're generating energy and heat as well. And then obviously burning fuel, whether that's wood or propane or gasoline, that gives off a lot of heat energy, right? We want those a lot of times to get nice and hot so that we can grill our steaks, roast our marshmallows, or create an explosion that allows cars to move forward if you're talking about gas. So sometimes exothermic reactions can give off light as well. Like obviously any sort of combustion will give off light as part of the reaction, but it doesn't have to. Like the little packets that you squish up and put into your hands that heat up your hands, those don't give off any light, just heat. But sometimes exothermic reactions, they give off so much energy that they not only give off heat energy, they also give off light energy, kind of like the light bulb that we were talking about earlier. So this match that's on fire, it's giving off a lot of heat and a lot of light. So it is a very exothermic reaction. Now, endothermic reactions. Endo is a science prefix that is kind of similar to into. So if exo is out, endo is into. So these are reactions that absorb energy from the environment. They take in energy from other sources in the environment, whether that be a heat source that's somewhere nearby or light energy from the sun. They are absorbing this energy. So usually they're doing this because they're making or they're building some sort of new compound, like the sugar that we saw in the photosynthesis reaction. Sugar is a pretty big molecule, C6H12O6. And so it takes a lot of energy in order to put that molecule together from the random bits of CO2 and H2O that the plant gets from the environment. So it has to absorb that sunlight energy. That's what gives it the energy in order to create this big sugar molecule. So it's taking in energy from the environment and using it to build some sort of new molecule. So you could be absorbing light energy like a plant. You could be absorbing heat energy for your reaction. But endothermic, all about putting energy into that reaction, absorbing energy out of the environment. So sometimes some chemical reactions that are very endothermic will result in a drop in temperature. So it actually will absorb so much heat energy from the area around them that they'll actually feel cool to the touch. Or if you put your hand close to them or on them, it'll feel cool when the chemical reaction is happening because they're absorbing lots of heat energy from the surrounding areas, which lowers the temperature in those areas. So that's not always going to be the case. Oh, there we go. You don't have to have a drop in temperature in order to have an endothermic reaction, but it does happen sometimes. So exothermic reactions give off a lot of energy, usually in the form of heat or light, and oftentimes they'll cause their surrounding areas to warm up. Endothermic reactions are all about absorbing energy from the environment, putting that energy into the reaction, into building these new molecules through these new chemical bonds. So photosynthesis, like I've been talking about, is an endothermic reaction because we're absorbing light energy from the environment, right? We're absorbing light from the sun and using that in order to form new chemical bonds for something like this big glucose molecule right here. So we're building this big molecule by absorbing energy that we get from the light from the sun. All right, so that is our major set of and kind of our initial chemical reaction notes. A little bit later on, we'll go into how do we kind of look at chemical reactions more on the formula side. How do we make sure that all of the different atoms are balanced in our chemical reaction? But we're not going to quite get that today. That'll be the next set of notes. So the homework for this chemical reaction notes should be pretty straightforward and follow pretty closely along with the notes that we just went over. So let's take a look at that real quick. So the homework for this assignment is the simple chemical reaction notes handout that has two different parts to it. So the first part is asking about what are the 6 signs that a chemical reaction is occurring. So if you remember early on in the notes, it mentioned 6 different ways that can signal that a chemical reaction is happening, that it's going down. And so all I want you to do here is list the 6 different ways that you can tell if a chemical reaction is happening. For the second part, we just talked about exothermic and endothermic reactions. So all I want you to do is write down the differences between what an endothermic reaction is and what it does, and what an exothermic reaction is and what that does. So pretty short notes and hopefully pretty straightforward homework. 6 signs that a chemical reaction is occurring and major differences between endothermic and exothermic reactions. So that's all we got for this assignment, pretty short and sweet. As always, please let me know if you have any questions about anything. You can reach out via text, send me an email, or ask a question on the Google Classroom, and I will get to it as soon as I see it. When you're done with your assignment and you're ready to turn it in, you can write down your answers and take a picture of them and text it to me or send it to my email, or upload the assignment directly onto the assignment page on Google Classroom. That's all for today. Again, please reach out if you have any questions or you want some more clarification. But for now, I will see you all back here for our next set of chemical reaction notes in another week.